All right, everyone. We got an agenda today. We're going to be doing some troubleshooting. We're going to have a great show. We're going to be PCB versus perf boards, embedded politics, and also we're going to have a channel update. So hope you guys stick around for that. We're going to see where the channel is going for the next year. All right, please do not forget. Please comment and please subscribe to the Engineering Bard Show. All right, so this is the troubleshooting tips and considerations. I'm just going to talk about this briefly. What you're seeing is the basic tools of electronics engineer or technician, engineer, any that type of sorts. And we're going to go through each one carefully. If you do not have any of these tools, it's very difficult to troubleshoot. So these are your eyes, these are your ears. Let's go off to the board. We're going to talk about soldering. This right here is my circuit. This is the circuit that I built. I painstakingly put in all these wires and pins right there, and I'm going to show you how if I make a mistake or there's like a little changeover, how I change it over. Okay. So let's say I want this capacitor out of here. Let's say there's no need for the capacitor, or let's say it's a smaller capacitor or a changeover or something like that. I use this vacuum gun right here. This is a very fast tool. It's faster than the copper braid. And what you do is just simply put your. I gotta take off my glasses. I actually see better without my glasses. You simply just put the nozzle right here and do that. It just sucks it out. So there you put my thumb, and this has like a little vacuum pump. You just kind of push down. It's already hot, so be careful. Okay, and then now you put it on this right here. There's a sponge. It's not the best, and then just take it out. That's it. That's how fast it is. You don't need to, solder that long. So if it's anything about speed, that's a good thing. Now, before I begin, I'm going to show you some. These right here are 8-pin holders. So rather than see this right there, hope you guys can see that. Let me see it real quick from a camera angle. Okay. This right here it's a dim switch. It's a dim holder, okay? Rather than soldering the chip to the board, which is kind of risky, you can see how I have a little tool right here where you just kind of just pull it out. Okay? Doesn't take much time, but if you got sensitive components, sensitive stuff, this is very sensitive. Not this chip per se, but there's other ones. There's some other integrated circuits that have a CMOS in there, and CMOSs are very sensitive to current. They're very fragile. The microprocessors, you don't solder those in. They have like a little. They have their own holder. They've been doing that for years. And so you just put it back in, and just like that, and just kind of takes a while. And you just put it in. That's it. So it's a few seconds. Now, if it doesn't have, let's say it's an odd shape, like this one right here is odd shaped, you can use these headers. These are called headers. And you could solder these to the board, and these are already come pre-soldered. But if you have to solder it, like I said, there was if you watch the last clip, I kind of show you why it's important to be careful. And this is a male end, and there's a female end. The male fits in the female end. I know, put a joke here. Okay, I've been doing this for a while. And you just put it on, you just insert it, and bam, it works. So what this does is, as a prototype, this guarantees that your soldering was not the cause, And so it's easy to troubleshoot and replace rather than using this tool and you got to go through and unhook it. Okay, so that will get you sort of, that's how I do it, and I hope you guys do it like that. When you solder, it's don't just solder. This is a fluxing paste, and you should always use a fluxing paste. It's a little bit gooey. Sometimes you'll see my table a bit sticky. That's because of this shit right here. And what you do is when it gets to, it makes it nice and smooth and shiny. This is a flux. So what a flux does, and this goes to welding, is a flux protects. They use flux when you build semiconductors. What it does, it's a substance that protects the weld, or the, how am I going to say? It protects the weld. So think of it as a protectant, and it protects the outside elements. So it forms this immune bubble. Okay. Meanwhile, in there is your solder. If your solder, what happens is outside in the air there's contaminants, and the contaminants will make the soldering, it'll put little holes in it, and that's a porosity. You can't really see it when you solder, but you can definitely see it when you weld. And so using a flux is more of a protectant, and it makes a very solid bond between the solder and the surface. Okay, so let's I'm gonna move on, and we're gonna just move on to the next section. I'll see you there. Okay, so next I'm going to show you some of the tools that I use. Some of the tools that I use to build this stuff. This is called a flush cut right here. Flush cut. This is for cutting wires, zip ties. This right here is a crimper right here. You want to use, this is a nice heavy duty, I think it's called Klein tools. Anyways, this right here, you want to use, don't use the automatic, there's like a ratchet. Don't use those. Those suck. I've used those, and they will, especially on butt splices, those are terrible. But these are good. These are awesome. They take a lot. You got strength. Some needle nose pliers. These are called snips. Okay, those are scissor snips. This is a Leatherman tool. Kind of has like stuff. It's kind of like a Swiss Army knife. There's like stuff in there. And these are your 18 gauge cutters. That's all you need. Okay. Now, to stay organized, otherwise with wires is everywhere, I had to design or build and design and tweezers. Don't forget these. These are tweezers. Those are very important. Also, a wire holder for the 18 gauge or 20 gauge with the wires. That's very helpful. Very helpful, very helpful. You don't want wires everywhere, and get wires organized. And so having a nice organized shop, especially when these little parts, saves the sanity, because otherwise it just becomes a big mess. And staying organized and staying on top of it is a very efficient way of getting your work done. I gotta say, I gotta always be careful about using these sort of like these pronouns. So when I say like your work done, I don't mean like you personally. I mean whoever needs to get done. All right, so let's go ahead, and the next section is the most important section. That is the engineering, the electrical engineering or electronic engineering. I'm going to show you some troubleshooting tools. These are very essential tools to troubleshoot your equipment. I noticed I get some Gmail comments, and they're troubleshooting their equipment without any tools. That's not a good idea. In fact, that's pretty gosh darn dangerous. Having the right tools is not only is important, but it's It's for safety measures. So we're going to focus on this fluke right here. This is a very high quality fluke. I don't know. I think is it built in Washington State? I'm not quite sure. Does anybody know? Okay, so one of the most important tools that I use for troubleshooting is the continuity test. Okay, hear that? So what that does is to determine that when you solder, you can test, like this is the board that I use, is a perf board, PCB board, and these are very, on Amazon, they work just like a breadboard. So on this, so you could test it. So from here to here, you'll hear a beep. That's the vertical lines from there to there. You should hear a beep. And then from here to here, it should be an open. That's good. From the horizontal, there's a vertical line. That should be an open. Okay, so that's good. These are your grounding. So from here to here, that should be continuity. So that's good. So we hear that beep. That's continuity. Another thing to do, we're just going to show it real quick, is the DC volt. That's all I use. I don't use the amp meter that much. It takes quite a bit of effort. It's because you got to put it in line with the circuit. I like and a lot of people don't anyways. So let's go switch it to the volt side. I'm going to turn on the power supply here. And what I'm going to do is just, oh wait, I got it going the wrong way. I'm going to crank this up to, yeah, I also got my oscilloscope. You see, okay, see that. So I'm going to put it up to 5 volts, let's say. And yes, see that? I'm going to try to keep it steady. That gives that's 5.3 volts. That's what I have. That's good to tell. It tells you the voltage. It may not tell you the power. Okay, so that's where you have to use a little bit of theory involved. Let me else do we have? So that kind of sells it with the voltmeter. There is a capacitor meter in here. I don't like that. It's not all that accurate. I mean, maybe I'm doing it wrong. I don't know. But I like to just read off of it. There's a millivolt scale. There's an AC scale too. That's important if you want to. You could plug this thing into a wall outlet to see if you have power. That's pretty important. Okay, so you want to plug it if it says 120 volts. It'll show that the wall outlet is live. Very important. I think this goes up to 480 volts, but I'm not quite sure what's the maximum. I'm not quite sure. Anyways, I don't know what's the exact maximum. But anyway, when you use these meter here, please use safety involved, okay? Next I'm going to show you is the oscilloscope. Actually, let me turn that on again. Let me see if I got my camera right. I want to do it all on one. Okay. Hang in there, folks. Hang in there. There we go. There. Look at that. See, now I don't have to. Come on, let me just adjust this baby real quick. Got this fancy dancy tripod. Okay, that's pretty good. Right. So on that line right there, if you guys can see it, I can't really see it, but sometimes the camera will zoom in. Yeah, I'm going to zoom in as much as I can. And you see a line right here. It says 2 volts. That's 2 volts per vertical line. So that's 2, 4, and then that's about 5 volts. This is pretty accurate. This is kind of an analogish type interpretation. So that also determines the DC, the voltage. And so you can always use that. Below this line right here is the negative voltage here. If it goes negative, don't think it's not, because it actually is. Okay, so if you see something weird like it's negative 5 volts, it probably is negative 5 volts. Not probably, it is negative 5 volts. Your instruments do not lie. People do. So always trust your instruments. Okay? I know I know what I said is a little controversial, but you guys got to hear it. Okay. Now, what I'm going to show you here is now we're going to talk about the signal generator that I have. And this is, I'm going to have to adjust it. So watch that carefully. And it's going to, if I do this right, hopefully I'm not going to muck this up. Okay, there you go. Okay, so that shows you can see on there it says 10 kilohertz. Okay. So that's going from positive. That is 10 kilohertz, and that's with no offset. So that's going positive 2.5 and a negative 2.5 with a total of 5 volts peak to peak. 5 volts peak to peak. So that's what that's showing there. So that's good to when you have to inject a signal. So when you get one of those chips, you might want to inject a signal. Okay, so you want to inject a signal. So that's just show you, oh, there is a flash drive. Did you guys see the flash drive? It's a kind of a turquoise, bluish, aquamarine, I guess. Is that the color? Well, anyways, that flash drive is to fit so when you can capture it, you can do a capture, and then when you capture, it'll go to the flash drive. There's other stuff in here. For right now, there's like a FFT and all that. That's for really advanced stuff, and that's for advanced signaling. We're not going to do that here, not anytime soon. That's kind of more advanced signals and systems. We're just doing sort of the basic stuff. Okay, so now, if you guys just be patient, so I don't have to keep on cutting camera. I'm going to move this tripod over. See that? Now that is your function generator. It says 10 kilohertz voltage. Okay. So it has, what's the most important thing for what we're doing is the square wave. I got that 5 volts, 10 kilohertz square wave. You can move the frequency so it's a lot slower by turning this to zero and then moving this over. Say you just want 5 hertz. Something like that, something like that. Now, what's most important is that offset. The offset. That offset, in order to have an accurate square wave, because that's going to go plus 2.5 and minus 2.5. We know that most signals that we use only goes up to 5 and 0. It doesn't go minus. So what you want to do is do your offset, and you want to go offset half that. So that's 2.5, 2.5. Okay, let me get, I know I was going to see this big old back in your way. Okay, now we're going to scoot over. So now I got a 2.5. 2.5, okay. And I messed with the offset. Can you guys see that? I messed with the offset. Can you guys see that? Okay. All right, so there's the offset. Has to be positive 2.5. Now let's go to the oscilloscope, and you can see that it's basically 5 volts. It's 5 volts. It's 5 volts. Okay? So I hope that helps. All right. We're back. We're going to do something. I just want to make a little interjection. I know we're going to be doing PCBs, and I'm just going to compare them and all that. But I just want to say that doing this YouTube thing, it certainly has broadened my horizons about all kinds of studies like photography and and audio, video, and lighting, all stuff that I had never really considered. So I'm kind of glad I'm doing this. I am glad I'm doing this, and I am glad that you guys are viewing it. So I appreciate every view. Now let's talk about PCBs, printed circuit boards. Now we're talking PCBs from a entrepreneur point of view, not necessarily from an engineering point of view, but from an entrepreneur point of view. We got the breadboard. You've seen these. These are cheap. Breadboards are cheap. Breadboards, as you know, and if you're a student, and even if you're just a hobbyist, they are not the best. They are kind of loose inside. The connections they're somewhat tight. If you got a 20 gauge connection perfectly, it'll fit. But if you got anything smaller than that, let's say you got a 24 gauge wire, which is very tiny, it might not fit, and so you may have a loose connection. And so even though you may have put it in right, your teacher might come by, or whoever comes by may see it that it's not in correctly. And so these things do have a lot of disadvantages, and so they're good for sort of small circuits, but as you get into bigger circuits, they're kind of problematic. Now, you graduate to this. This is what I got. This is what I got on Amazon. Is the Epsilon PCB board. These are brilliant. I wish they were a bit bigger. Hint, nudge, nudge. They're a little bit small. Make them bigger. Okay. And then this one right here is a professional PCB that I did. It's a professional PCB that I did. I didn't do this, but I went on KiCad and I designed it. I don't know if it works correctly, but I will find out. Certain designs are going to take this PCB. That's too small, and it takes a long time. So when I did this board right here, it took me about a day and a half. It took a long, long time. I was working really hard, okay? That is a long time for one board. And so, but it's cheap. I did my own labor in it, and I built it. Now, what if you got a big board? You got bigger than this. You want bigger than this, and it's way complicated, especially if you're doing maybe doing your own microcontroller. I don't know. You decided to do your own. You're going to be your own thing. Okay. Now, when we talk about PCBs, there is a little bit of concerning politics involved. Politics, a little engineering, politics, okay? And I'm going to discuss this. This is my editorial personal opinion. And you could, my opinion is either bullshit or it's true, but I think I'm like right in between. When you do a PCB, you got three options. Okay? You've really got three options. Okay? Option one. Now, this is a professional. I already discussed about the perf boards. Okay? This is PCBs. This is a professional. Okay? So you need to hire somebody to make it. You kind of have three options, and it's up to you guys to decide what options you want to take. I just want to consider some of the options. So option one is you outsource to China. Okay, outsource to China. Okay. Here is you do it in your own country. Okay? In your own country. Okay, and here is yourself. Okay, this is like you have your own PCB. You're doing it yourself. Okay, so option one, let me put this in the center. Internet, go on the internet, and he says, oh, PCBs, prototypes for $20. $20 for a prototype. Made in China. Made in China. Nothing against Chinese people, okay? There really isn't, okay? But we're having here in America, it's sort of we're here in America we're trying to get away from that, even though we still buy a lot of stuff from China, even though there's a tariff. There is a tariff here, okay, in China. $20 made in China, okay? Now that is cheap, and that is a really good deal. That is an awesome deal. $20 for a prototype PCB. PCBs, as you know, they get cheaper when they get a huge order. Like if I'm going to make an anti-gravity platform, let's say, and everybody wants to buy this anti-gravity platform, then I said, okay, I want 1,000 PCBs a month. Then they're like, $1 a piece. They get really cheap. But when they're prototypes, they're expensive, okay? Because you only want 3 prototypes, and they don't make a lot of money. It's like, well, 3, shit, that's not a lot of money. So they charge a lot. Even in just $20 for a PCB may seem expensive, believe it or not, it's really super cheap. The problem with that, now it's cheap, and that is good. It's also very risky. For Americans, that is risky. And for anybody else, it's risky. Okay, it's risky. That option one is risky. Why would Americans who ship their designs to Chinese be risky? It's an obvious answer. You're leaving your option one is risky. You're leaving your designs to be exploited and sold. Okay? Exploited and sold. Okay? Let's face it. Everybody, everybody got to do what they got to do. And, if you got someone who wants to, hey, you heard about the engineer Bart's design? I heard he's making the anti-gravity platform. How much do you think you sell that for? Because I want to make it too. Oh, I'll sell it to you for $1 million. Okay, here you go. Well, okay. You sold my design. I can't sue that guy. They're in China somewhere. Good luck trying to, good luck. Now you're up against Chinese courts. So I'm not, just want to say that, okay? Just want to say that. This is an American station, okay? Now, that's cool. That's cool. Option 2 is doing it in your own country. And that's what I did. Option 2. You're looking at it's about $200 to $500 for 3 boards. And I'm being pretty generous. $200 to $500 $300. And that's in my state, on the West Coast of the United States, from Washington, California. So that kind of gets you. That's a lot of money. That's a lot of money. But it's a good option. Is it the safest option? It's not the safest option, but it's the best option. However, your designs are in the hands. Your designs are in the hands of a stranger, but, and it's a stranger, but it's local. You could do a lot of stuff if it's local. You got a lot of local laws and all that. So they sign a proprietary agreement, something like that, a legal agreement. Okay, so they'll think twice before they decide to sell you out. and that's actually not bad. That's actually not bad. A lot of people do that. You got to trust people, and that's not bad. But now we know the option 3 is now, and that's 200, but that's not the most expensive. Option 3, and a lot of the big ballers do this. Texas Instrument, Qualcomm. Option 3 is the guys like, Qualcomm, Microsoft. Oh, give me a break. Boeing, I don't know. Give me a Boeing. This is option 3. You're probably going to guess it. They get their own machines. And don't get me wrong, they're exactly what I just said. They trust nobody. Because their PCBs are highly proprietary, government contracts, all that good stuff, top secret type of stuff. They're about $200,000 for a machine. I mean, that right there is a lot of money. So that's just kind of giving you an idea of just basically you get what you pay for. Okay? So yeah, you get what you pay for. Yeah, $20 maybe. If it's something that you don't really care about, $20, hey, whatever. If it's something that you kind of care about, but you want to be kind of a good guy, hey, go local. If it's something that is super top secret, buy it yourself. And that's when we're starting talking about big bucks here. Hopefully that will kind of understand about engineering politics. We got more. There's part 2, okay? Hope you guys stick around, and let's go off to part 2. Part 2 of engineering politics or embedded politics. And I am your host, the Engineering Bard, a.k.a. Andrew Dunlop. We're going to talk about what happened. I think it happened in September. Arduino got taken over. Our beloved Arduino got taken over or bought. I don't know, taken over. That's a bad word. Maybe they merged with the Italian designers called Arduino. And for anyone know, Arduino, if I had to do, let's say I had to do like a tier list, and let me show you. I think I do have a couple Arduinos. Here's Arduino right here. And I've been working Arduino since 2018, and I worked with a few years. And then I just recently changed the brands back. If I something I did with a Pi. Well, Arduino, hate to say this, and I know I might be turning coat, and I know I flip-flop. It's probably the best. I said it. And the reason why it's the best is because of its stability. Okay? The stability is very reliable. And I'm going to discuss something kind of abstract. So this is the Arduino right here. And they got the Arduino. And I heard there's the Arduino Q, which is, I think it's like, I just briefly looked at it. It has like a microcontroller and a microprocessor. I think it's a microcontroller, microprocessor. Is it a Snapdragon? I'm not quite sure. I'm not quite sure. But they use one of those type of process. The fact is, and they might make the microprocessor dual channel means, or dual core, has dual cores. There's a lot of vocabulary in this. Dual core. And making it dual core means you can have the weight functions. You can have like weight this, and then you could do another weight, which is not the same thing. But you know what I'm saying? It's the weight functions that you want that because you don't want it to weight. Okay, so this right here is the Arduino Q. Okay, I put the big old Q, giant fucking Q. Okay. Qualcomm is they consider it sort of an intimidating force. And they're my neighbors, so I got to be careful. They live like right next door. Hi neighbor. Don't want them come home and have a burning cross in your front yard or something. Sorry, I was just. Okay, I thought that was freedom of speech, but maybe not, and my international friends, believe it or not, are a little bit afraid of them. I do have some international friends. And they got some questions. And I'm not the guy to answer. They say that your scripts will go into a Qualcomm database. And they have your scripts. Is that true? I don't know. I don't know if that's true, but you do have to hook up on the internet. Is it the same thing with the scripts that I use? You got to log in. I don't know. I really don't know. They probably do. I don't know. So it challenges open source. What is open source? And, so there's a lot of people out there. There's a lot of inventors out there that Arduino is probably the easiest microcontroller to use. It's actually easier than the one I use. It's easier to use. It's more reliable, and it's more stable. And I took it like a controls class where you try to make these things stable because we had to use a very open source IDE, which was very difficult to use. So we had to use controls theory. Basically what all I know about controls theory, it was a quadratic algorithm to compensate for its unstable behavior. That's not good. Arduino over the years, if I put in a code, let's say I put in a code for the code, it does exactly what it's supposed to do, and it's absolutely amazing. There's not like I put in a code, what's going on? It doesn't. It is one of the most stable machines that I've ever worked with. Just saying, hands down. Now, let me erase this. The big intimidating Q. I've dealt with Qualcomm very briefly, and I've done a couple interviews with them, a couple job interviews with them, and the tech industry is so. Let me put this: the tech industry, we've been hit pretty hard, haven't we? Life's been tough for us. It's been a blues song, It's been tough. 100,000 jobs lost this year. 100,000. Who knows? Last year, they're not hiring. People are not buying. People are not buying cell phones. People are not buying computers. I mean, in fact, some of my friends are still on i5, something like that. Intel is almost had to declare bankruptcy. The mighty Intel. I mean, to me, that's just insane. But we need the tech industry. The tech industry, we need the tech industry. You want your tech industry to go like this. You want tech to be this. And you want your health industry to be, well, not necessarily down. I mean, if it goes like a bit down, like slightly down, that means you got a healthy economy. That means people are living and not going to see the doctor. You don't want your health industry to be up. That means people are dying. So yeah. So I'm just saying it from a big thoughts point of view. You want to make sure, so if you guys can see that, yeah, the middle class have taken a big hit. I mean, there's here in the economy, we got two classes. We got the haves, and we got the have-nots. The haves and the have-nots. And I want everyone to have something. So I get kind of misty-eyed a bit when I write that down. I really do. I really do. If you want to avoid Arduino, that is fine. You could always use the Embed Studio. I picked that thing. That was like the redhead. Nobody even heard of that until I came on. So Embed Studio is awesome. So you got the Embed Studio. You got the, God, that looks terrible. Hold on, let me write that again. It was like the redheaded stepchild. Just sitting there by itself, I'm like, hey, you want to go on a date? And I just, Embed Studio has a great, I think there's called an STM Cube. So there's the Arduino, okay? Arduino, I got, their IDE.cc, STM Cube. There's the Embed Studio, okay? All these you still have to log on. Now there's one that you don't have to log on. And I got this, I've never used it. It's Verlog. This thing is a pain in the rear. If you can get this damn thing to work, I mean, that's basically the most open source you can get. It is difficult to use. I mean, good luck getting that thing to use. You must be somewhere down the line, it takes someone like that to understand. I don't have that type of capacity. I like simple stuff, but somewhere down the line, someone took a blinking LED and they turn it into a computer language. I think maybe the ancient aliens was talking to that guy. Who knows? I don't know. Okay. So the bottom line is, okay, hold on. Let me add a bit more. Qualcomm has been in the embedded business for a long time. All these guys. Let's say I build the platform, the anti-gravity platform. It's this platform that defies gravity, and it uses 10 microcontrollers to operate this thing. It controls all these little functions. And let's say it's going gangbusters. I'm selling it. And I used Arduino, okay? Qualcomm would, everyone would love to have an order of 100 Arduinos a day or something, or maybe even 1,000 Arduinos a day, to one company making this anti-gravity platform. And that's pretty much what what I believe Qualcomm is shooting for. I also believe what his competitors are shooting for. I think all these guys are shooting for. When that time crosses, now I'm not saying by me. I don't have anything to invent. But if you're a guy that's an inventor and you want to use that, and you're going to come up with something, you're going to have to do some negotiation. You're going to have to be brave. I highly recommend. There's a movie out there called A Flash of Genius. It came out 2000. I think it's 2007, 2008. And it was about a guy in the 50s who invented the windshield wiper in the 50s. And he had this patent on, he was a professor in the Midwest area. And he decided to give his invention to Ford. Was it Ford? Ford? Something like that? Ford? And this was an old film. And so I guess they took the windshield wiper and they stole it from him. And so he had to, he was just an average guy, and he had to go against Ford, or was it Chevy or Ford? And he ended up, Ford just dragged this guy through the coals for like 20 years, long. He lost his family, had 10 kids, lost his job. Eventually, justice was done, and he got his money, and he got it, and they finally paid him for what his business was worth. Those are great stories, okay? So highly recommend, if you're an inspiring inventor and you're concerned about these guys beating you up and all and raking you the coals, it has been done before. Don't be afraid, okay? If you got an idea, just crank it out there. If you want to use the Arduino Q and it's part of it, who knows, or if you want to use one of these, who knows? I think all these guys will give you a hard time. It's litigation. This is what I know. This is what I know. Okay, so I hope you guys listen, because you guys are. I know you guys. Some of you guys are entrepreneurs, and some of you guys are scratching like, who the fuck is this guy? Litigation is a process, not a punishment. Okay? This is from personal experience. This is from family experience. So litigation is a process, not a punishment. By having litigation, make sure that by having litigation, it makes sure that each party gets a good deal. I want a good deal. A gets a good deal. B gets a good deal. And that's what it's all about. That's what it's all about. So hope you guys enjoyed that. I think that was between truth and bullshit, but I like to be in between. So stick around, and we're going to talk about an update. So the channel is doing okay. It could be doing better. The channel, the EB show, is it's doing okay. It's doing okay. It's doing okay. But I need 100 subs. I need 100 subs is huge. So if you like my content, please don't. I need 100 subs. But why should you get 100? Why should you subscribe? 100 subs to me is a YouTube kind of a coach-like thing. We're talking, and these guys are about $100 like a month. So basically, Engineering Bard, if you want to think, I'll get this shirt right here. So, and that will make it more professional. It'll be like, okay, you need to crank up your audio or something like that. They'll actually It'll kind of motivate me because I am my own boss. I am my own boss, and being my own boss, I could be horribly lazy. Horribly lazy. I could just drink beers and play video games and just kind of walk around and just get into trouble. A YouTube coach is like having a boss that I have to pay for. So it's like YouTube 1 EB 0. I'm giving YouTube a point. So that's why I want you guys to subscribe. So it's only 100. We try to find 66 more. You can hold it to me. Say, Andrew, you said you got a coach. I want more stuff. Okay. I used to work hard. I used to work 12 hours a day. But so thank you for watching. If you enjoy it, and I'll see you on the next Engineering Bard Show. Thanks.